In this section, we're going to see if we can use the information that we've already had and determine messenger RNA codons, transfer RNA codons, and then amino acids from the genetic code table if we know what the DNA template is. So what you need to do is write down this DNA template. Then take a few minutes and see if you can determine the messenger RNA codons first. Follow the Watson-Crick model. Join C with G, A with U, T with A. There's your first messenger and RNA codon. Now see if you can complete the rest. I'll give you a few minutes to finish that. When you get your messenger RNA codons, again, following the Watson-Crick model, determine your transfer anticodons. Now, transfer RNA has to attach to messenger RNA temporarily, following the Watson-Crick model again, and again substituting thymine with uracil. So take a few minutes and see if you can determine your transfer RNA codons. Don't worry about the amino acids yet. Now, when you get the transfer RNA codons, you'll see that they look almost exactly like your DNA template. The biggest difference is, though, wherever there was a thymine in DNA, you've substituted uracil for an RNA. All right, here is what you should have determined. If this is your DNA template, here are your 4 messenger RNA codons. Then following the Watson-Crick model, here are your 4 transfer RNA anticodons. Now, how did I get these 4 amino acids? Well, you do that using what's called the genetic code table. Now, the genetic code table uses the messenger RNA codons. So we're going to disregard the DNA, we're going to disregard the transfer, and we're going to look at these codons right here of messenger RNA. Now you notice it says first letter, second letter, third letter. That's referring to the first, second, and third letter in the codon. So our first codon is GUA. The first letter is G, so we go down this column till we find G. The second letter is U, so right here is the U column. Then the third letter is A, so here's G, U, and now we have to find the line that is A, which is right there. So our amino acid for the messenger codon GUA is valine. Now, the second codon is CUG. So C is the first letter. There it is. U is the second letter. There's the U column. See the U. The third letter is G. So there's the G column. So CUG would be leucine. The third codon is GGG. So the first letter is G. The second letter is G. Here's the G column. And the third letter is G, which is here. So glycine is our amino acid. The fourth codon is CGU. So we go down and we find C. We go over to the G column and up to the U line, and that is arginine. Now, what if your mRNA codons were AAG? AAG, lysine. But what if your codons were AAU? AAU gives you asparagine. All right, let's look up GAU. GAU, aspartate. GAG, though, would be GAG, glutamate. All right, so remember this with the genetic code table. You use your messenger RNA codons. That's why I've written mRNA up here at the top. Now, this chart is on the test, and I'll give you a DNA template. The first thing you'll have to do is determine your messenger RNA codons. That'll be a test question. Then you'll have to, using that same template, determine the transfer RNA anticodons. That's a test question. Then the last question dealing with this template would be, what are your amino acids? And I'll give you this chart. And when you determine the amino acids, you forget about the DNA, you forget about the transfer, and you look only at the messenger RNA. First letter, second letter will be one of these, third letter here. So like A, C, G would be threonine. C, A, U, histidine. So do you see how you use your genetic code? And if you don't understand that, you need to email me. Lately, there have been some scares in the news where people have received ricin powder. And ricin is made from the castor bean plant. All parts of the plant are very poisonous, but especially the seeds. And what it does, it removes adenine base from rRNA in the large subunit and shuts down protein synthesis. That's how it kills the person. This is what the castor bean plant looks like. These are what the beans look like and the leaves. A lot of people grow castor beans as an ornamental plant in their yard, not knowing that every part of that plant is very poisonous.